their nuclei. The nucleus is different. One of the ways that they can be identified on a smear that has been stained. This is a small portion that can be found in the makeup of blood, because even though we're looking at the parts of blood, it's not just red blood cells, white blood cells, platelets, and plasma. We're going to find there's a lot more stuff in blood than just that. Now, Morgan, you were kind of mentioning this earlier, taking it and centrifuging it down, okay? Any of y'all ever done that? Or worked anywhere?
I've seen it done.
Okay. Worked in biological lab for a couple of years before I went back to school after my master's degree. And so I actually worked in a lab that we tested plasma for drug levels. In other words, for companies that were developing drugs. It was to perform chromatography on the samples to see the levels of the drug. I'll never forget the time that I went to go get my sample, and you had to let the sample thaw, okay, because the plasma had to remain frozen, okay, and I let my bottle of plasma thaw out and then dropped it all over me. I'll never forget that, because I mean, you know, you don't know what was in that, okay, what you might have gotten exposed to and stuff like that. So that was a lot of fun. When you do this, and this is one of the things we'd have to do, love the centrifuge. And the one thing you never do is open that centrifuge before it stops. Okay, never do that, because they'll all break and it'll burst all up in your face and everything else. Now, when a blood sample is taken, they can centrifuge it, and this is how it will separate out. You'll separate it out with red blood cells at the bottom. We have what's called the buffy coat that's going to contain the leukocytes and the platelets, and the rest of it is the plasma. So when this is done, you often hear the term hematocrit used. Okay? They might say, what's the hematocrit of the blood? And hematocrit is going to be what is the percent volume made up from the red blood cells. So if this came out and, okay, so we're going to do the percent, we got 55 here, 45 here, less than 1 here. But let's say I took the sample and I centrifuged it, and the red blood cell portion was up to here, and the plasma was the rest of the way. What would that be indicative of?
Is that leukemia?
Well, it would just tell me there's an overproduction of the red cells, okay? And that's not good either, okay? And they would have to begin to do, you know, studies to find out why. Now, in the makeup, okay, in the components, the parts that we see here, where if we're looking at red, we're looking at buffy, we're looking at plasma, okay? The red cells, the reason that they settle out first, they're very heavy. Their structure makes them heavy. So anything when you centrifuge it, the heavy parts settle out first. So that's why red blood cells settle out to the bottom. Now, white blood cells and platelets, under normal circumstances, should only be a small portion of that makeup. okay? If it's increased, then you know something's wrong, because that's telling you there's a lot of white blood cells in there, okay? Now the plasma, the rest of it gets very complex. One of the biggest components of plasma is water. It's roughly 70%, 75% maybe, water, depending on your body weight and depending upon your fluid intake. All right? It will affect how much water is actually in the blood. Now, in the plasma, we're going to see water, proteins. Why?
Because blood is for transporting.
Okay, and the stuff that's going to transport are proteins. Nutrients. What kind?
Minerals.
Could be minerals,
Vitamins.
could be
Sugar.
vitamins. Okay. How about the electrolytes? Our sodiums, our ions. Okay. Wait a minute. Nitrogenous wastes? What's a nitrogenous waste?
Isn't that for urine output?
It's going to
Whatever
be
gets filtered through.
the filtering that's got to take place. Liver, kidneys, okay? Our hormones, which we just finished, all those little chemicals flying around in the blood. Gases. What kind of gases? Methane?
Carbon dioxide, oxygen.
Our carbon dioxide and oxygen. Anything else? Inert nitrogen. Inactive. Take a break. Back at 12:30.